Hey guys, welcome back to the Tin Man Saw Lab or Bike Lab or Diesel Lab, whatever we're working on. You guys know me. If it's an engine, I'll probably work on it. Sometimes we do welding here. Welcome to the newcomers. Today's video, I want to show something that I've never showed on the channel. I was thinking the other night, I have never showed this. How do you measure cylinder to piston wall clearance on a whatever, chainsaw, Harley, diesel? How do you do that? What tools do you need, and how do you set those tools up to do it? Piston wall clearance is super important. You could have a piston that slides freely in your cylinder and have a what they call a cold seize. It does happen. I've seen it in chainsaws. Guys fire up their saw, and then they blip the throttle and it locks up solid. Then they pull it apart and it's like, I don't know what happened. Motorcycles, especially Harleys, they run really hot. They're air cooled. A lot of expansion goes on in the cylinders. If you're sitting in traffic, these things will get hot enough to burn the insides of your legs. I see guys riding Harleys in shorts in summer. I would never do that. But again, I usually have never had a stock Harley. A built Harley will belt heat out at your legs. So piston fitment is super important, and it also depends on what your pistons are made out of. Let's go to the bench. I will show you the tools that you use. I'm going to do it on a Harley cylinder. This applies to any piston and cylinder combo. I don't care if it's a chainsaw, a lawnmower, a diesel engine, a Harley engine, a sport bike, a car, whatever. It's the same on all of them, and it's the same tools. You can buy expensive tools or inexpensive tools. As long as you trust that they're calibrated, you can do this. So let's get to the bench. Okay, we are at the bench. I have my used pistons and my used cylinder. Now, I have to order pistons for this because I had issues with the rings, and I decided for the cost, I'm going to go brand new pistons. Now, if you get into a situation like this, you may be going, wow, I am in over my head. Do I need a machine shop? Can I do this at home? Well, that is up to you. You could take these to a machine shop with your brand new pistons and have them fit the pistons to the bore and fit the rings to the bore, okay? I'm not going to do that. I'm going to do it myself for two reasons. One, I'm a cheap guy. I'm a cheapskate. I don't like to spend money on things that I can do myself. Whether it's working on my house, changing the oil on my car, working on my diesel truck. You guys have seen that 6.7 Cummins I bought from the auction. I did a ton of work to that. I didn't pay a penny for labor. Okay? Now, a little bit easier for me. I grew up pulling wrenches before I got into the sheet metal trades. I already have a lot of tools and the knowledge to do it. But here's the thing, friends, with the internet, Facebook, YouTube, you can learn how to do anything and what tools to use. Okay, so let's flip this cylinder over. First thing, you want to check that your cylinder is in good shape. These are in great shape. You can still see the crosshatch. Nice 45-degree crosshatch. They appear to be straight, okay? Now, when you slide a piston into a cylinder, this one, a lot of guys will go like this, okay? This cylinder goes like this. This is the exhaust side. This is the intake side. You can always tell the intake side because of wear, okay? So this piston goes in this way. Guys will put their piston into the cylinder and go like this. Side to side and front to back. Oh, this thing's got a sloppy piston. You got a lot of piston clearance, okay? Well, that is incorrect, okay? The reason for that is on a two-stroke piston, it is continuous from top to bottom. On a four-stroke piston, this is machined in. Okay, you ride on the rings here. I don't know if you guys can see that, but there is a step. You can feel it, okay? This is thicker than this. So if you go side to side, well, there's no skirt there. You are not, you're not measuring it correctly if you go side to side. Front to back, I can feel a little bit of play. Just a hair. There should be play, but the question is how much play. Now, if you want to measure your cylinders, you can do this. This is like the least accurate, cheapest way. You get a set of gauges, snap gauges they call these. How these work is when you turn this, okay, they unlock. Pick the size that you want, and then you can go in, okay. Now you got to hold these straight. Let's go halfway down the cylinder. Okay, halfway down the cylinder, and lock them in. Okay, so this should be my cylinder bore. Now, most people, if you work on engines, you probably have a set of micrometers. These are not expensive ones. These are ones I use for chainsaws. But you can go in here and get a rough measurement. Okay, now what is the measurement supposed to be? I'm measuring 3.9355 right now. 3.936. Okay, well, I know that this is a 98-inch build. These cylinders should be bored to 3.937. So I'm 1,000th off already. Close enough for ordering pistons, but not good enough for what we're doing here, okay? So I'm just going to fold this in because it fits nicer in this case. These will get you out of these will measure something in a pinch. They are a handy tool to have around. They're cheap. I recommend having them, but that is not the way to do it. What you're going to want is a micrometer. I have 5 or 6 of these. They come with a wrench to zero, a gauge. This is a 3-inch gauge. I'm not going to use that. I know that this thing's zeroed. I zeroed it last night. Okay, so these are a little bit different to read. I'm going to get you guys in here real close. Okay, what you want is you want 0 to line up with the first line. You can see the first line. If these line up, see I've gone over 0. When you're at 0, it should touch the edge of the line. These are perfectly zeroed, okay? Now, how you read this is a 3 to 4 inch mic. And see, it says that, and it's a 10,000ths mic. Okay? So that bottom line is 3 inches. Every time I turn this around, every hash mark is 25 thousandths on this. And the way you know that, okay, spin it around, 5 thousandths, 10 thousandths, 15 thousandths, 20 thousandths. 0 is 25 thousandths. And at 25 thousandths, there's your first hash mark, okay? So what I'm going to do, I know approximately now how big this bore is. It's 3.9 and change. So I'm going to spin this around until I hit 3.9. And I know I'm like 3.930 something. So I'm going to go 3.9. First hashtag right there. Hash mark, that's 25. 30. 35. 40. I'm going to go 3 inches. 940 is how you would measure that, okay? 3 inches, 940 thousandths. Now I'm going to take these. When you order pistons, they will give you a measurement, where to measure them, okay? I am just going to measure these halfway down. Okay, usually you want to measure them about, it'll give you a measurement a half inch down from the skirt. You want these to be 0 in the center, okay? And you turn this until it clicks, okay? And when it clicks, that gives the same amount of pressure. And you want to move these and see how tight they are, okay? Okay, now, in this case, I'm going to measure these at the bottom, just for ease so that you guys can see what's going on. Remember, don't screw it on here, because if you screw it on here, it's going to be too tight, right? Like, look, I can really tighten this. This is calibrated. Okay, and then you lock it. And let's see what it's telling us these pistons are. 3-inch, 900. See if we can zoom you guys in here. 25, because you see the one hash mark. 30. 31, 32, 33, but that one doesn't line up. Now you go around, find the one that lines up. And it is right here. Go down there. So these things mic 3 inches, 900, 25, 30, 1, 2, 3. 3 inches, 933, 8. Okay? Okay. 3 inches, 903, 3, 8. Okay? So they're almost 3 inches, 934 thousandths. Okay? And again, you'll get good at this. Check in several spots. And again, I can slide this over the piston, and it's a nice tight fit. Most pistons will have a relief here. If they have a coating like this, they will have a relief, and that's where you mic them. Okay, so one more time, I'm just going to check it. Just to make sure that we didn't mic something silly. Okay, we'll lock this down. 3 inches, 925, because you see that hash mark. 30, 1, 2, 3. 933.6 on this one, okay? So you can see by varying where the mic goes, we might be 0.2 off. Okay, now I'm going to leave this locked. There's our piston. Now the question is, how do we measure the bore? Okay. Well, you're going to need one of these. This is not a super expensive one. It's not a super cheap one. This is a bore gauge. Okay. Right here. Okay. Now, what this consists of, you have a dial or a digital. This one's digital because I'm a young punk and I like reading my digital readouts. Okay. And all this does is, if you look, there's a feeler here and it moves in and out and look. Okay. So what you want to do with this, it says different anvils in it, or this one's 3.8, this one's 4 inches. Well, we know the 4-inch one is not going to fit because we don't have quite a 4-inch bore. So we take this 3.8-inch one that I just dropped, Precision Tools dropped on the floor. Okay, we take this one, we unscrew this, we pull this out. Now, this is 3.8, and we know this bore is 3.938. So what do? One's too long and one's too short. Well, we have a couple of little rings here. This one says it's 0.1 of an inch. So if we put that on there, this is now 3.9. And we know that we're 3.938. So this one is 50 thousandths. So now this assembly is 3.950. It is slightly bigger than the bore, right? Than what we're measuring. Okay, you then screw that on. Okay, and we'll move this out of the way. Now what we want to do is we want to zero this. We know that this is 3.9338. Okay, so what I'm going to do is I'm going to turn this on right here. And I'm going to put this in the bore, in the micrometer. Okay, I hope you guys can see this part. Okay, and I'm going to center this in there so that it's measuring perfectly. Okay, I'm going to find the biggest measurement. That's 27 thousandths. What I'm going to do is I'm going to zero this. Okay, and when I line it back up in the center, it zeroes back every time. This is now zeroed. Okay, now what I'm going to do is, again, you can do this with any cylinder in any motor. I'm going to run this into here. Okay. Now, this is going to say 0. Look at your bore gauge. When I push this in, it says plus. When it comes out, it's 0. Minus, rather. Okay. So this is plus, meaning smaller, and this is out, meaning negative. Okay. So because we zeroed this to a smaller size, it should be reading negative. Let's see if we can get you guys right in here. Okay, and what you're going to do is you're going to move this all around. Okay. And you're going to move it around until you get the smallest number. Okay, and our smallest number is, okay, 3.5 thousandths of an inch. Now, I'll bring you guys up with me here. Move it around here. 3 inch. Bring it all the way up. Notice it's about 1,000th difference. Okay, now look where I'm at. Well, that's where the piston never touches. Okay, so we would expect that to be, okay, you can see this piston goes down to about here, and then there's no wear. Okay, so I want to measure where the piston's actually going to be. And again, if we start where the piston is actually running, we're 2.5. Right in the middle here. Okay, you guys get the idea. Sorry if I ran you off there. Okay, so we know, friends, we know now if we look at this, we know if we look at this number and we add 3 thousandths, 3.5 thousandths to it, okay, plus we'll say we're 3.5 thousandths. I measured this last night, and it seems to be consistently 3.5 thousandths. Now, also, my cylinder bore, everywhere that the piston touches is consistent. I get the same measurement. So what does all of this mean? Why am I measuring this? Well, this is a forged. The pistons I'm putting in are forged. And this is 2618, I believe, aluminum. And 2618 aluminum. For a street engine, you want your pistons to be minus 3.5 thou. 3.5 to 4 thou is what they say for these pistons. So, friends, as long as my new pistons are they are for a 3.937 bore, which is what this is, okay? Therefore, 3.937 bore. And these pistons are for a 3.937 bore. And these pistons are roughly, we actually measured a little bit tighter. It was more like 3.9336, okay? So we know if we add 3.5 thousandths to this, we end up with 3.9371, okay, or 3.937, which is exactly what this bore should measure. Now, the reason why I'm measuring this so carefully, This saw is 105%, or this cylinder is 105% overbore, meaning I am 5% over max, okay? That's what a 98-inch twin cam is. It's 5% over max. It's a wonderful engine. When guys first started building these, there was a lot of arguing, oh, they're going to blow up, you can't do that. This motor has 80,000 kilometers on it, and the only reason why I open it up is because I have old style Wiseco trackers with that's the small oil ring, and it was burning oil. There's no wear in this motor. Okay, so I know my cylinder is 3.9371, so it is 1/10,000ths over that 105 spec. Okay, so I know that my new pistons are probably going to mic somewhere around here. Apparently these coated pistons mic slightly oversized. So I might end up with 4,000s. I might end up with 4.5 thousandths. And that's okay. This is all within spec for a forged piston. So what does that mean for me? Well, that means that I don't need a machine shop. I'm going to run my dingleberry hone through here, this big thing, which will deglaze. Those don't take off much in the way of material. That is a misconception. People think, oh, you need to use your 3-stone hone. And it's like, no, that is for removing material. The dingleberries are for deglazing. That dingleberry will probably remove about a 10,000th. Okay? But even if I remove a 10,000th, I'm not going to be over the specs that I'm looking for. Me personally, I would rather have these pistons at about 4,000. Just because of the material that they're going to be and how much expansion. Forged pistons that are 2618 alloy, they're a softer alloy and they're a higher expansion piston. They're also lighter, more malleable, less prone to cracking. These are a good choice if you're running a boosted engine or a high compression engine, which is what this is. This thing, the way this thing's set up, it's anywhere from 10.5 to 10.75. I wouldn't go any higher. My old motor was 11, and it was a little bit of a bear to start, and it ran very, very hot. So there you guys go. That's how you measure cylinders. You can buy one of these, buy it in the size range that you're going to use. Caliper. This whole setup's going to cost you maybe $150. And you're off to the races. This will work on everything from, this is a 1.4 to 6-inch bore gauge. So this will literally cover every bore that I work on. I can mic this bore out of a chainsaw or this bore. Well, this bore is double the size of this, and it'll work for both of them. So good stuff. I hope that helped you guys learn something, and good times. Okay, guys, well, post a comment below. Is this the kind of stuff that you want to see? I've never showed this on my channel, but this is important stuff. If you were building any motor, I don't care if it's a grocery getter or something that's high performance, a professional engine builder, the guys that build power and reliability, this is the stuff they do. This is what you're paying for. A good engine build is worth a fortune these days because a guy will spend hours and hours and hours and hours measuring and fitting. You're basically blueprinting the engine. Could I buy a set of pistons and slap them in here? Yeah. But the problem is I might whack on this thing, build a lot of heat and stick my pistons, and then I've blown up my motor. So I would rather buy the tools, measure the bores, and do everything, get everything within spec, throw it together, and then I know that I have no issues. The only other thing I didn't show is fitting piston rings. That's pretty simple. Feeler gauge. And file them either with a ring filing tool or a file. And away you go. 3.5 to 4 thousandths per inch of bore. So this thing being roughly a 4-inch bore, I wouldn't want them too tight. I'd be closer to 4 thousandths. 3.5 thousandths per inch of bore. So my top ring will be 14 thousandths gap. My second ring will be 18 thousandths. That one should be 3 to 4 bigger. and then my oil ring. So that's how that all goes. Anyhow, friends, thanks for watching. Take her easy. Later.